Hydraulic lift. For the hydraulic lift shown in figure, what must be the ratio of the diameter of the vessel at the car, D2, to the diameter of the vessel D1, where the force F1 is applied, so that an M equals 1520 kilograms car can be lifted with a force F1 of just 125 newtons. So here is the hydraulic lift. We apply a force here and the car can be lifted up. Now we know Pascal's law. What is Pascal's law? When you apply a pressure on one side of this hydraulic lift, that pressure gets transmitted in the fluid to the other side with no change. So the pressure that we're applying on the left side is the force F1 divided by the cross-sectional area A1. It's the same pressure that is transmitted to the other side, and that is the force F2 on the other side divided by the cross-sectional area A2, and these pressures will be the same at the same level. All right, you can see here we have the same level, the same pressure. Now the pressure F1 divided by A1 is F1 divided by pi. If the diameter of this part is D1, it is D1 divided by 2, which is the radius squared. And this must be equal to the force that we're applying on the other side. The force is due to the weight of the car. So it is F2 is equal to mg divided by the cross-sectional area pi d2 over 2 squared. So we have, we're talking about diameter, therefore it's a circular region here. Now we can see that these 2's will cancel, the pi's will cancel, and I will find that F1 divided by D1 squared is equal to mg, the weight of the car, divided by D2 squared. So we will find that the ratio of the diameters, what must be the ratio of D2 to D1? D2 divided by D1 is square root of mg over F1. Now we can substitute the numbers. The mass of the car is 1520 kilograms. Gravitational acceleration 9.80 meters per second square. F1 is 125 newtons. So this gives us a ratio D2 divided by D1 is now the weight of the car, 1520 times 9.8 divided by F1, 125 square root. So the ratio is D2 over D1 equals 10.9. All right. So we talked about a hydraulic lift. We have different diameters for these vessels. The vessel at the car and the vessel where force F1 is applied. The pressure on this side must be equal to the pressure on this side at the same level. The pressure gets transmitted to the other side according to Pascal's law. So F1 over A1, the pressure on this side, is equal to F2 over A2, the pressure on the other side. The force here, F2, comes from the weight of the car, and the cross-sectional area of these vessels are pi d1 over 2 parentheses squared and pi d2 over 2 parentheses squared. So by equating the pressures on the two sides, we see that d2 over d1 is square root of mg over f1, and when we substitute the numbers, we obtain a ratio of 10.9.